All right, so let's jump into this. Microsoft Fabric. I was talking to to a friend of mine, another MVP, the other day, and we were, just joking about what would be the mindset of these people inside Microsoft when they give products their names. Like Microsoft SQL Server is a great one, right? They took the SQL language name and made a product out of that. So it's great. That name is super cool. But there are some other names that where did they came from? Like Synapse, the version before Microsoft Fabric, right? The predecessor of Microsoft Fabric. How did they came up with Synapse? If you do a little research, you see it comes from human physiology, and it's like when our neurons they exchange information between each other. So it has to do with exchange information, but we went out of IT and tech world into human body terminology. So it was kind of interesting to see that one. And when Microsoft Fabric came along, the name Fabric came along, we start joking about that. Where did this come from? Fabric is like this fabric here or something. And I don't know, there are some areas in the human science, human exploration, especially in the space, where they say that fabric is the fabric of space is what connects everything, and it can be bent and it can be compressed and all of that. How light travels over the fabric of space and all of that. I don't know how they came up with that. To me, it's like a patchwork. Microsoft got all these services that they already had in Synapse and some other places in Azure, and they patched them together and they made a fabric. If you got the drill, a fabric with all these services already integrated, connected to each other, and ready to use, which is great. Not sure if that's the mindset. It works in my head. I hope it helps you make sense of this. But the other side of this approach is there are too many, not too many, but there are many services inside Fabric. If you look into the fabric, the fabric in architecture, we will see that there are so many options in there. And that's one of the things we'll be looking into and focus on a couple of them or three of them as we move along into the demos. So the agenda for tonight, let me see. I hit the space bar here. I hope I did not stop anything. It's getting here. There we go. So the agenda for tonight is we're going to do this architecture review of Fabric, see what's in there to make sure we are all on the same page. And then we're going to take a look on the Spark engine. It's one of the elements inside the Fabric architecture. And we will then go into the SQL engines that are in there. Because the title of this presentation is lake houses or warehouses. Which one should I go for? Or should I do both or none? Because there is an option in Fabric to use none of them as well. And the Spark engine is in the Spark engine singular, and the SQL engines plural are the ones behind those two options. So we'll see them as we move on. All right. So when you go into Microsoft Fabric, in the home page of Microsoft Fabric, and here's where this thing is going to give me trouble to switch, but I would make it work. There we go. Come on. Where are you? Must be this one here. Nope, not you. You then. It just disappeared. Maybe you. Okay, it's you. Yeah. So when you go into Microsoft Fabric, when you do fabric.microsoft.com, the homepage they show up in there. There we go. This one is the one where I took those icons from. Right. This is what Microsoft tries to present Fabric in the first glance, and it has to do a little bit with the personas there are there in Microsoft Fabric, which we're not going to be discussing them today. But this is around what you do inside Fabric, right? And you have, for instance, you have data science. Oops, come on, go away. You have data science. This thing's not cooperating. You have data science in here. You have data engineering here, which are some elements inside Fabric and some engines that are there inside Fabric. Power BI is right here. So this is what they try to give you an idea about what you can do inside Fabric. And if I go back to my slide deck here, put it back up. So all of these options we see on the screen right now, they are at least one engine to process either data transformation, or to orchestrate the processes that are doing the data transformation, or to deal with streaming data that's flowing, all the time as they happen in the real world. So all of these options here, they really are specific engines. They're usually they used to be by themselves in Azure, and now they're all integrated inside Fabric. When you look at this one here at the corner, right at the top left corner, when you see the OneLake, some people look at the OneLake and say, the OneLake is not really an engine, right? Because OneLake is just the storage, is where the data is kept. And we discussed that as we move along, but it is the storage where the data is kept inside Fabric. But there is compute going on in there, because there is security that happens at the OneLake level. In Fabric, we have security happening in multiple layers. And as they happen, these multiple layers, they're evaluated at each layer individually. And the last layer, the bottom layer, is OneLake. And there are specific permissions that can be applied at the OneLake level. So there is an engine in there that looks into the metadata around our data, around our files, and evaluates and retrieves and lists what's in the folder, for instance, and things like that. So all of those things there, they are data engines. It's important to keep that in mind, because even the title of this session is a little bit misleading, because I gave you two options. Should you use the Lakehouse or should you use the Warehouse? And as a matter of fact, this is the two most popular ones, but there are others. Like in Fabric, you can use Power BI by itself. You don't have to use the Lakehouse or the Warehouse if you want to just get like what is used to be a P1 capacity in Power BI. But now we want to have Fabric available for you in case you need to do some thinking there. But you just want to use Power BI as you've always been using Power BI in Fabric with the new capacities that are in Fabric. You can do that. It's totally okay. And then you're not going to be using either the Lakehouse or the Warehouse or anything else. You would be using just the VeriPack engine, probably doing the import mode or dual mode, whatever you're doing there before, and it will work just fine, right? So you don't have those two options, right? The Lakehouse and the Warehouse. That's one of the things you must keep in mind when you're looking into Fabric. Fabric is not a transactional system, right? A line of business system. At this moment, as it is today, Fabric still is an analytical platform for us to process data, for us to transform data, and for us to analyze data and do machine learning if you want to, right? Create vector databases for Copilot, for the open AI models and all of that. So we can do all of that inside Fabric, but it's not just those two options, right? We have Power BI for once. If you look into the real-time analytics, just to finish wrap up this larger vision of the other engines that are there. If you look into the real-time analytics, this guy here, the data engine that's in there is the Custo, is real-time analytics data engine in the Custo language, right? It's a little ambiguous there. Sometimes they call Custo the actual database, but I think it's the language, KQL, Custo Query Language. In any case, that particular database engine, the KQL database engine, is the same one that Microsoft uses inside Azure to collect the telemetry for the entire ecosystem. The entire Azure, everything that's in Azure, they collect the telemetry and analyze that telemetry using KQL databases, and that's what we have inside Fabric on real-time analytics. So if you have a customer at some point that is like, let's say it's a cell phone company, right? One of these carriers, and they want to collect the telemetry from the devices that are connected to their network, and they want to collect that telemetry to do analysis in real time. You can do that in Fabric at scale. Actually, there are some carriers out there doing this today using the KQL engine, and they're not using the Lakehouse or the warehouse, right? None of them. They're using that specific engine inside Fabric to do real-time analysis and time series-based queries on those kind of data. So yeah, open your mind, right? Fabric is way more than what we're going to be talking about in here. And each one of these options on your screen right now, they are about compute, right? They are about data engines that can process your data. In this slide here, I'm kind of rearrange what we had seen before. So now they are in boxes. And I'm trying to highlight here the two ones we are going to focus on tonight. And these are the data warehousing and the data engineering sides or boxes inside Fabric. Now, I was at Microsoft back in, we are in July, I think it was back in May. I was there in May, having some meetings there with the product team. And I did meet the guys who create the documentation for the data warehousing and the data engineering. And if you look at the Microsoft documentation, they refer to the lakehouse or the warehouse as a data destination. Now, if you look at the learn.microsoft.com and look for these guys, these two options inside the Fabric, they usually refer to these two options as data destinations. And what I actually forked the GitHub page and submitted a PR to them to review that that terminology and how they named that, because it's a little bit confusing. People get a little confused because the data destination is not any of them. The data destination, as you always have heard from Microsoft, is OneLake. So OneLake is where the data really resides. The data doesn't belong to a data warehouse or to data warehouse or just the warehouse or the lake house. The data belongs and is stored, physically stored at the OneLake. Those two options over there, they are just compute. They're just they're just engines able to go to OneLake and collect the Delta tables, and in particular for the data engineering, work with other types of files as well, to grab the data and process that data. So the first thing I need to keep in mind when I'm making these choices in between the warehouse or the lake house is that the data is stored in one place and it is available to any other data engines that are there on the screen, right? Once the data is in OneLake, I can query that data as long as I have permission. I can query that data if I use the data, if I used the Lakehouse to get the data into OneLake, I can query that data from the warehouse. I can query that data from Power BI using VeriPack and the semantic model that's in VeriPack. I can use that on machine learning. I can use that on real-time analytics. I can use that from anywhere, right? From any of the engines. And this is one of the beauties about Microsoft Fabric, because in the past, SQL Server used to have its own data type. And if you want to use SQL Server for a large amount of data, you're going to use the dedicated SQL pool in Synapse or the Azure SQL Data Warehouse before Synapse. You have to move the data into the storage, proprietary storage for that engine. And if you need that data available somewhere else, you need to move that data out of that engine. So a lot of data movement in there. Fabric breaks those silos by having one data storage type and destination to all the engines. So your choice in between the lake house, the data warehousing, the lake house, or the data warehousing, the data warehouse, your choice in between these two is not where the data will live. Data will live in OneLake regardless, and will be accessible to any of these two or the other ones, no matter what. So if data destination is not, that's why I made that pull request to the documentation. So you should not say data destination, right? You should refer to these things as what they are, right? They are just the compute engine that will process the data, either when you are ingesting or when you are doing the transformation. So my choice in between these two, again, is about the engines and what the engines can do. Now, it makes my life a bit easier, right? Because if my choices are based on what I can do, I just go and look at the features of what these two guys can do and start working with them. So let's take a look. Let's jump in straight. This all the slides that I have for tonight. Let's jump into the demonstrations, right? So let me stop this. Actually, I have one more here to wrap it up, but these are the slides that I have. And let's go here. Yeah. So I have a workspace here that I have created earlier today for these demos. This one here, actually, where is it? This is the regional. I think it's here. Yeah. For some reason, this was not showing here. I'm doing a refresh here. Let's see. Funny stuff. Still not showing for. Am I looking the right place? No, not looking the right place. Now I'm looking. There we go. This is the one. This workspace here. All right. Mark, is the font big enough? Can you read well?
Yes, I can read it fine. If anybody has a problem, please let us know in chat. Thanks.
Perfect. All right. So as you can see, I have both in here, right? The lake house and the warehouse. They're both there. And I have created the two of them. And for this particular session, I'm using the data set, that very popular data set from the New York City. Let me see here, from the New York City tax cab. So New York City taxi data set download. That should get me there. These guys here, right? So I'm using these files in here. They used to present this thing here in CSV format, and now they are working with they convert the whole thing to Parquet files. So you see everything now it's Parquet, which makes life supposedly should make life a little easier. I'm telling you, I've been working with this data set here for a while, and there are some boot traps on some of these files there. But fine, we not the top for the day. So here's the thing, right? This is about the demo. I want you to get to this web page, and I want you to download all the Parquet files that are from there, and I want you to create. I want to have my Delta tables in my Fabric OneLake based on the files that are in here. So these files, first they are not Delta tables; they are Parquet files. Even though Fabric and the engines that are in Fabric, most of them can read Parquet by themselves. We want to have those files implemented as Delta tables, because Delta tables is the type of the file format that really goes across all the data engines, right? So we want to have that, which means I should go, if I look into one of these files here and I look one of the links there, let me grab this link here, for instance. Copy link. And let's go here, Notepad just quick. Go a little tab here, yeah. So if I see the link in here, this seems to be on a cloud frontend service somewhere. It's probably pointing to some AWS S3 buckets in the back end, and I have these Parquet files. Life would be great if they could give me, the link, access to this particular link in here, and I could go and just list the files and collect them all. But that's not how they made their files available. Actually, there is no other resource than what I see here on this web page. So I need to ingest this data. There is no open storage or old data source or any kind of other source file share, some sort of file sharing there. There is just a web page with all the links. So my only option in here is to scrape this web page, get these links, and then start reading these Parquet files one by one. Even worse, these Parquet files over time, they change, right? Some I don't remember which particular year they start adding a few more columns, so the actual structure of the Parquet files are not fixed, right? Are not equal across the entire data set. So there's a lot of a processing you need to do there. Scrape the web page and then collect the files and bring that in order to bring that data into OneLake, into Fabric, and land in OneLake. So therefore, the question is, what is the data engine that would give me the flexibility to scrape a web page, collect the links, and read the Parquet files, process the Parquet files, mix with whatever I have already read, and then save as a delta table, right? In OneLake. So you see, the real question about which one to use, the lake house or the warehouse, is based on on features. And now I have a use case, and I need to look at which one of them can I use. There will be another option here later in this presentation where we're going to see the feature on both, and then I'm going to share my decision criteria with you on which one I go. But in this particular case, I have no option because the warehouse, the actual data engine in the warehouse is the SQL Server engine, right? If I go back here to my slide deck just quick, retrieve this guy back. What I have here, I make a note here, my screen is not touched today, so I usually write on these things, but today I can't. So I'm going to use here text box just quick. So the actually data engine here is SQL Server, and this thing is in black. Let me get it into white so you can see, and bold. So the engine that is in here is working in the data warehouse, I'm sorry, not this one, the other one. Move around here. The engine that's working here is the actual SQL Server. The SQL Server we know, on premise now we have SQL Server 2022. The same core engine that is in there is the one that's working here. But in fact, the one that's working here, it comes from the predecessor of Fabric. And the predecessor of Fabric is Synapse. So let me go, just to give you context, let's go back to Synapse here a little bit. If you have never seen Synapse, don't worry. I'm not going to go deep dive into Synapse, but I just want to show you what I'm referring to inside there. So I have the portal here already open for us. Actually, I think I have the studio here somewhere. I think I had it. Nope. So let's go back here and try it again. Let's go to this guy, Synapse, and open the studio. It's pretty sure I had the studio open. Go figure. Going once, going twice. Actually, I can actually show you from here. If I go into analytic pools, yeah, there we go. I can show it from here. So here in the analytic pools, I have here the SQL pool, See the SQL pools that I could have. And here in the SQL pool, I can go and create what they call a dedicated SQL pool. I'm sorry, there's somebody on the door there. If you hear some ringing here, it's someone knocking the door in my house. So there's this dedicated SQL pool. So this engine that is inside Microsoft Fabric is the same, is the what we see in, I'm sorry, I just got a little bit distracted here with someone on the door. Let me focus again. So this SQL engine we see inside Synapse, in Microsoft Synapse, is the same one, but of course the next version, with all the improvements that they're able to do over time, that we see in Fabric, in Microsoft Fabric, under the warehouse name. So the warehouse name there, I think if we go back to the front page, they will actually call it Synapse. So Fabric, Microsoft.com. We may see, you see, Synapse Data Engineering and Synapse Data Warehouse. So this Synapse here is a reference to the engine that was there in Microsoft Azure that was made better to work here inside Microsoft Fabric. So it's exactly the same engine we see over there. And this is one of the engines, right? One of the, there'll be another one in a second. So when we work with the Synapse Data Warehouse inside Fabric, or the warehouse inside Fabric, what we have in there, it's what SQL can do. And when it comes to get data outside where SQL store its own data, SQL is not very good at that, as you may know, right? We do have a command to ingest data into warehouse, which is the copy command, right? And when you do Fabric, when you do warehousing Fabric, there is a SQL command copy where you point to external sources. And as of today, you can only point to Azure storage accounts, right, in the data lake. It can be blob, but data lake works better. So a DLS account inside Azure. So you can point to a folder or container in there and ingest the files. If those Parquet files were in a storage like that from the New York City data set, CAB data set, I would be able to collect from there straight inside the warehouse, but they are not. And the warehouse doesn't have any command or support to scrape web pages from anywhere on the web. So the warehouse is not an option for me, right? The warehouse, in order to bring that data in, is just not an option. So I ran out of options. There were just two. I have to do that in the lake house. And again, I have to do that in the lake house because what we have in the lake house is what, again, came from Synapse, which is the Spark pool, right? These guys here, right? We have the Apache Spark pool. So, Apache is the repository, right? It's the open source repository that's there with, hundreds and hundreds of open source projects hosted in there. And Spark is just one of the projects that were there. The story about Spark, I'm not going to get into that. But Spark, Microsoft went to that repository, got the Spark project from there and forked it out and made it specific for Microsoft Azure, to work with the Azure infrastructure, and built it into Synapse first, and now into Fabric. So that Spark pool is what is backing up the Lakehouse. So the option for Lakehouse is not an option for a destination. The destination is OneLake. The option for the Lakehouse is the engine that will be processing my commands to grab data from some place inside Fabric or outside Fabric, and storing usually inside Fabric. And the bottom line is, for the most part, the Lakehouse, because of the engine, because the Spark engine that's in there, is usually the go-to data engine to do data ingestion when you need this kind of flexibility that I just mentioned. There are other engines to do data ingestion inside Fabric, right? We can use, data flow, Gen 2. We can use data flow, the traditional one. We can use a couple others, right? Copy activities, like I said, but they all have their limitations. If you really want to do what is named data engineering, that's why they take these options in data engineering. If you really want to do data engineering, you ought to go to use the lake house, because in the lake house, when you jump in there, I already ran my thinking here, so there'll be some data there already, right? I got two of the data sets in there. Oops, one of them is not okay. Hopefully this one is. Okay, this one is processing. Okay, so what we have in here, it looks like a storage place, right? Because we have the lakehouse name in here, we have the tables in there, and we have the option for files. So the bottom line is, if I want to process, to have flexibility and use the Spark engine with the flexibility that Spark engine gives to me, I have to choose the Lakehouse. And as you know, when you do Spark engine, we usually write code in using notebooks. So here I have a notebook here. Where is it? Ingest writes, this one. Ingest writes. And this notebook here does what I just told you, right? I wrote this code here, this sample code here, to scrape that web page. And the bottom line here, the code is not important, right? I'm going to share this notebook with Mark later, and Mark will publish where this presentation will be. But the point in here is, I'm a data engineer. I need some flexibility I can find anywhere else. So Spark is my go-to thing. And actually, this is the portion of the code that actually goes around and scrapes the web page. Where's the web page? The web page is over here. Yeah, this is the web page that I just showed you in there. So it goes in there, gets all the links. There are many links in there, many kinds of links in there. We're just looking into the data sets, one to the Parquet files. And as I run through the Parquet files, I populate my data frames in here with the data coming from the Parquet files, doing a union, and then make all the things in there. You see, I'm able, because I'm doing this union here with the union by name, by column name, it gives me the flexibility. If one of the Parquet files is missing a column because it's from the past, so that data was not there, so it's able to bring it in and add it up to the data that is present. It's more accurate, and so missing columns will not break. The whole library helps me out here. So this is my place to go for this particular scenario, right? And my choice in between the lake house and the warehouse was based on on features. And because it was based on features, this was the only engine with the feature that I needed. So there we go. Here's just as it was reading the data in there. I got this one here. I think that's this guy here with 16 million rows. Yeah, so we'll see this guy later, right? This is not the point here. So the next, once that I have my data there, here's my data, here's my yellow rides. And if I go, actually, it's down here, right? If I go, what was the last count for the yellow rides? The yellow rides here. Last count was 22 million. Yeah, 22 million rows. And this is not all of it, right? I was just sampling some 15 files to get started with, just to run some tests in there. So again, the file is in there, the data is available. And now that my raw data that I brought from external sources, right, my scraping web page is available in Fabric, right, stored in OneLake. And as a matter of fact, if I click this guy here and I look at the copy, if I look into the copy path, I think, let's see here, get a cell just quick. Yeah, so as you can see over here, it is on the tables folder, right, on the yellow rights folder, and there, all the Delta information is inside there, inside OneLake. So this one here is the generic, it is the ABFSS link to that file that can be used even by external applications if they have the authorization to get into OneLake and consume from their side, bypassing all engines inside Fabric, bypass all of them but OneLake and get through the OneLake and collect the information. Like Databricks would use this one here if I need to consume that particular table from Databricks. So, okay, so all my files are in there. My next step would be like, because they provide a very consolidated data frame, right? It's just one set of data there. There's no other tables around it. And I'm going to do, I want to create a star schema model based out of this data. So my next thing is to start collecting distinct information for each one of these columns that I decide to create a dimensional table around that, and work with that table, right? Create that table over there. Now, my first criteria was like, I need to do data engineering, scrap web pages, write to OneLake. Lakehouse was the Lakehouse engine, the Spark engine, was my only option. Now what I need to do is select distincts and create tables based on select distincts on each one of these columns in here, or the columns that decide to create dimensions on top of, and then create my fact table on top of that, and perhaps do the SCD approach on top of it, and all of that. So if I want to create this table on top of the data that is already a table, right, in Fabric, is already a Delta table inside Fabric, if I want to do that, now I have two options. I can keep doing it inside Lakehouse, if I want to do that, or if I have two teams, and one of the teams was the team responsible to get into the data and bring the external data and bring that external data in. Now, the second team is going to take over and work with the data that was made available inside Fabric and work their case on top of that data. And that's a very common scenario inside Fabric. It's a very common scenario inside Fabric. One team handles a portion of the task. The next team picks over after that team and implements more logic, more transformations, whatever needs to be done, machine learning training, whatever it is, based on the data that was created by the previous team. Now, in the past, if we were using regular engines, we would have to do data movement in there if I want to handle to another team with another platform. But in this particular case, let's say that my second team, they are well-versed in SQL. They rather work in SQL Server, and because it's easier for them, they feel more comfortable in there, and they kind of have some logic that's already in SQL. They just want to adjust that logic to work inside Fabric. In this particular case, because I'm already in the tabular world, right? I have a table available in Fabric for me. I can use either one. And because my team and my criteria here, because I can use either one, the features are available on both. The next step is, what is my team more comfortable working with, right? As long as it doesn't impact performance and things like that, what is my team more comfortable working with? And if my next team work with the data, it's going to be myself, but if my next team, right, the other side of me, work with the data, is well-versed in SQL, they can come in here and get this data that's in OneLake already, and just read it from the folders where they are and write it into other folders. And that's one of the things that most of the people, when I jump into a project and they're not familiar with analytical approaches, they are a little uncomfortable, or they are like not accustomed to the approach that in analytics we don't do updates, right? Parquet files and Delta tables, for that matter, they are read-only files, where you write once, read forever, right? Write once, read many. That's how they call it over there in some documentation, some white papers. So you write once, you read many. These Parquet files, they are read-only. Inside SQL, we have column stores that those column stores, they can append to the compressed information the delta changes that happen to the compressed data in there, but that impacts performance on that particular way. So it's the same approach we used to have in SQL, but now as delta tables inside OneLake. The bottom line is, regardless if I use Lakehouse or Warehouse, the next step on any ETL, when I do the first ingestion, and then I do the ETL, and the next ETL, and the next ETL, is always like reading and writing. Reading and writing, and when writing, we are writing someone else. We may be writing in the same Lakehouse or Warehouse, but we are writing to new tables all the time. We may be overwriting tables that are already there. That's also possible. But usually are reading and writing someone else, right? So it really doesn't matter if you are doing the transformations from the Lakehouse engine or the Warehouse engine, the SQL engine, because even if you do Lakehouse to Lakehouse, you are reading and writing back to OneLake, just using the same engine you used before. So if I want to go into this guy here and let me go back here to my workspace and go here into my warehouse over here. Yep. New York City cab warehouse. So if I want to come in here and see, there are no tables in here. Let me see. Yeah, it's pretty empty, right? The schemas are here, DBO tables, and I got no tables in here. So if I want to grab that data from there, you may have seen this before. There is this feature in Fabric called the shortcut, where you can point to tables that are in one particular folder in OneLake and work with them, read from where they are, and write to the destination where your engine is. So if I go ahead here and bring in the cab data that I created before, right? We're just looking at it. I can see that it will pop up in here for me as it was another database, right? So this is my database over there. This is the yellow rides that we have seen there. The green, something happened to the green, so we don't have to worry about that. But the New York data is right here. The columns are there too. And in this particular case, from the SQL perspective, from the SQL approach, the only thing I have to do in here is reading that data as it was in another database. So some people, they get confused because Microsoft decided to use the same approach that they have in SQL Server for cross-database queries. So, when you do the query in here, it feels like you're doing a cross-database query. But as a matter of fact, the only thing you're doing is you're pointing to a new folder, to another folder in OneLake. Let me see here if I have thinking here. Let me see if it's there. Oh, yes, it is right here. So as you can see here, there is this extension for Windows File Explorer called the OneLake Explorer. And in here, you can actually see the, oh, it's not refreshed. It's not showing my thinking there. From here, you can actually see the folders are created when you do OneLake or the other. Let's see if there is a way for me to refresh this thing. There should be a way to refresh this. Sometimes it just takes a while to pop up. Well, I can do this one here. It's not the same one we're looking at. This is another one that I have. So you see, I have the New York City Cab Original Lakehouse. See it over there? And the Lakehouse is just a folder. See a suffix for a folder name. And in there, I will find, well, this particular one is empty, but I would find the Delta tables that are there and the other files. And if I want to process, I think I got the Parquet files here, yeah. If I want to process like non-structured or semi-structured data, they would be stored over here. And if I create a warehouse, there will be just another folder in here with whatever warehouse name I gave to the warehouse. So this we're looking at here is at the OneLake level. right? From the web interface, I can't see this. I have a glimpse when I go into the tables and see the files that are in there. Like if I go here into the New York City data lake house, and I believe if I click here, I can see view files. So here's a glimpse of the files that are in there. Got only one file there, 300 megabytes of data in this particular file. And this one here is a glimpse, right? That particular file would be in OneLake in this place like this, right? In a place like this. Too bad this thing is not refreshing. It's still in preview. That's why Microsoft is like, if it's taking forever, it's not under SLA. So if it's not showing, it's not showing. But it will show eventually. Let's see if it shows now. Nope. They had an option here to refresh. I don't see the option anymore. Yeah, not there. I think they removed it. Anyways, so it will show up here eventually. And as you can see, it's just a folder. So when I go into, is it this one? Where was that? This one. Back in the warehouse. Here's the warehouse, I think. Yeah. So when I go this and do a query that's going to look like a cross database query, it's not actually a cross database query. It's just a translation to a folder place inside OneLake. So all the permissions are already resolved. You are in the workspace, the security thing has been resolved by your Entra security principal, your Entra ID, your account. So your permissions are already evaluated as you query this thing. It's just a query to that. The point is there is no performance impact when you do the query from either engine, right? The engine will define pretty much how it's going to read. The Spark engine may behave in a particular way. That SQL would behave in a different way when reading the data from there. But bottom line is there's not much of a performance impact. So if I want this guy here, and if I want to create a select from this one here, it's process the select. That is the data that came from the table in there. And as you can see here, is just a cross database query. So if I want to, internal shortcut follow. So let's say here that I want to do a dimension based on passenger count. I have a dimension in there. I want to make sure, I want to allow people to select and analyze rides based on how many people, or how many persons, right, were inside the ride, right, the taxi or the Uber or whatever it was. So I could come here and do like a select distinct passenger count and nothing else. Should I have here a primary key for this? And discussions that we're not gonna have in here, right? But when we do this kind of things, you never have a primary key, right? You may have a key that doesn't repeat, and that may help you with the joins later in the semantic model. But the primary key, in the sense that there is a database constraint in SQL, it's a metadata. It will be there in the descriptors, but will be never enforced, right? Those things are never enforced because in analytical, you have to make the data the way you want it to be. So if this is supposed to be distinct, unique, you make it unique, right? You have to cleanse the data. Therefore, we have the ETL. So we have this one here, and we do the famous CTES. Create table passengers dimension as select, and then we run our query, and we have the dimension table for the amount of passengers on a particular ride created. And if I go here into my new cab, I will probably be able to see here. Let's do a refresh. The interface sometimes takes a little, there we go, right? We got it there. And based on other CTES approaches like this, I go from the folder where the Lakehouse stored its information, bring the data in, and then I create my dimensional model out of that by doing a bunch of C-tests. That's one of the approaches we can use. Could I do that on the Spark? Yes. Which one do I want to do? Well, the one I have, since I can do them both, the one I'm more comfortable with, and that would produce results faster, both from the team that's coding this and also as the processing doing this. So when this one is created, it's the same Delta table format, but remember, this is a different engine. So when you do Lakehouse, there's a Spark behind the scenes, and you may be looking into partitioning, right? So we can support partitioning pruning if you have that large amount of data updating there. When I do this in here and I decide to bring the data for the fact table from whatever sources I have ingested, and I decide to use the warehouse, then the warehouse, when creating the delta tables, the delta table for the fact table, will not have the same approach, right? The data warehouse will not use the partitioning pruning approach to reduce the amount of reads on the delta table files. It will actually use that approach of distributions. That's the same approach we saw in Synapse Analytics. So in Synapse Analytics, there were 60 distributions, and we defined the key to organize the distributions in there. In here, in Fabric, what we have is the engine that's being made better, like I said, it's been improved, and it's not limited to 60 distributions. I think you can go to 1,024 distributions in there, and you can reorganize the data in a way that distributions would be left out if a particular criteria would be given to the query, right? So it's not based on, in this particular, the warehouse option here, the data engine doesn't work with partition pruning. It works with distribution selection, right? So then again, when it gets into performance things, you have to be aware of the specifics to see which one you want to go, depending on how you want to process the data and work with the data. And from here, I could go back into the Lakehouse if I want to query that data from the Lakehouse. From this dimensional table here, and if I want to, I don't know, create some vector database on this thing here, a vector database, a vector collection, in order to export it out and save in Cosmos for OpenAI to read that, and through the orchestrator work with the OpenAI models to do embedding or grounding, whatever we want to do with that one. It's also available because everything is in OneLake, right? And then I'm jumping into another engine or back into Spark to create those vectors there in Spark. So I cannot create those vectors in SQL for now, right? Microsoft is working. There is already a project out there in public preview to create those vectors from SQL as well. I think it's going to go into SQL Server first, and then it's going to come in here. I think that's what I heard. But yeah, so for now it's only Spark. So if you're going to do that, you have to do that in Spark, and that's how you come to choose, right, which one to use, or none of them, right, depending on what you do. The bottom line to wrap up the session today, the bottom line in here is here, this one. The bottom line in here is it's not a choice of where to store the data. It's a choice of which compute engine offers you the features you need and the agility for your team to implement the solutions based on that engine. Right? If the features is one particular engine, you got to use that one. If it's both, your team has flexibility. Regardless of which engine you come to choose, they can always read data from each other. Before I forget, there is one extra thing here that I had in mind to talk to you. I think we still have a couple minutes. When we created our our warehouse, we got the warehouse there, and we got a semantic model in that warehouse. So the semantic model is out of the scope of this session because the semantic model is my connection to Power BI, right? Semantic model is the metadata for the very pack to work with the tables that are in OneLake and through the whatever engine we're doing within here and bring that data in. Now, here's the point. When I do a warehouse, I have the semantic model. But when I do a lake house, besides the semantic model, I also have this SQL analytics endpoint here. What is this SQL analytics endpoint? The SQL analytics endpoint, if we go back to, no, not this one, where is it? If we go back to Synapse here, if we go back to Synapse, we will see inside Synapse, let me see here, data, should be data, no. Let's get in here, let's do a new SQL script. And here on my SQL script, it's been a while I've been presenting this one here. I think this one is corrupted. But there is an option here in the SQL in Synapse called the serverless SQL pool. And I don't believe it shows anywhere else. You know, I have SQL pools in here. These are all, oh, there you go, serverless right here. It seems my account doesn't have permission, which is funny. Anyways, there is this serverless SQL pool here. This serverless option inside Synapse, it was created to query data from the data lake, the data lake, the ADLS. And the data lake was there when the data was there. The data could be in CSV format, or in Parquet files, or in Delta tables, right? It can be one of those two, one of those three. Because SQL can work with the engine was already, this particular engine is a different engine from the warehouse. This engine here is, the code name for this engine is called Polaris. If you Google it, you're gonna find it, you know, Project Polaris from Microsoft. And they have a white paper about how this thing works. It's an amazing thing. I have another session on that one if you want to if you want to learn more about how this thing works. But what it does is the SQL engine that is specialized on Delta tables and Parquet files and CSVs to collect the data from the lake and present as it was a SQL server, even though it's not. So it creates all the metadata, or kind of fakes the metadata around the table. So we have the schema, you have permissions and all of that that SQL Server stores on its own storage. Based on the file storage. So this engine here is the one we see here on the SQL analytic endpoints. So this one here is not the same SQL we see over here in the warehouse. Because in the warehouse, you can do data transformations, right? It's designed to do ETL based on T-SQL language. This one here is designed only for querying. You can do some sort of CTES there, but there's a lot of limitations, so it's not recommended. The CAT team tells you not to do any data transformations based on this particular engine, because it's a SQL engine, but it's a tailored engine just to query data, in this particular case, created by the Spark engine, and it's a read-only approach. So this one and this one creates a SQL interface that in terms of reading, they're compatible to each other, where the VaryPack engine on the semantic model can read from. So that's why we have the semantic model associated to both. And that's the default semantic model, but that's a talk for another day. What I mean to emphasize in here is for you to understand that there are two distinct SQL engines, one in the warehouse for ETL, the other one in the Lakehouse that is just for collecting data, just to query data and serve that data to OneLake. To Power BI through the semantic model. All right, and the data is in OneLake. So with that, I will jump into to wrap up the lecture portion of this one. So I see you in the next section. But before we leave, I would like to open the floor for questions. And that's my favorite time, right? When we are able to chat. So Mark, do we have any questions there?
So we have not seen any questions posted to chat except around setting up Fabric accounts, like a personal Fabric account, which I responded to that already. So questions that anybody has, you can come off mic if you'd like, or you can type into chat. Either one, totally welcome. And if you're shy about questions, we are going to end the meeting in just a moment. We'll have a quick close of the meeting, and if you want to stay around afterward, that's just fine too. But questions from the group now?
Come on, guys.
Well, I will break the ice. So
it
is clear that we can choose either of the engines depending on their capabilities. Do you have a cheat sheet that says for these weird capabilities, use this? For the 95% of the projects that we normally do use this? Or some kind of more cheat sheet?
That's a great question. I may write one. I don't have one, but I may write one because, again, it's based on the feature. So it's not a difficult task to create this kind of cheat sheets. Because, like I said, I on purpose, I brought the New York cab data set because I could only do that on using Python libraries, right? It was not even Spark for that one. It was regular Python libraries inside Spark. So if I need that particular kind of flexibility, but I need to write code that's not really related to data transformation, but specifically for data ingestion, Lakehouse, 99% of my cases, Lakehouse is the engine that I use to ingest data into Fabric. Besides that, as much as possible, I try to rely on the warehouse for data transformations, especially to create the dimensional model in order to support the semantic model, because it's already in SQL and written on SQL engine. So the interface with the semantic model doesn't have to have that man in the middle. That's the SQL endpoint. And it tends to work a little bit more straightforward. Either one works just fine, but having the dimensional model there. So therefore, when I create a dimensional model in the warehouse, the whole thing is in the same language, is in the same environment. It's easier for the team to maintain. Does that make sense, Gonzalo?
It makes sense. I will give you a caipirinha when I see you.
There we go.